Okay, so here we are with example 1G, and in this case we see the parent function, which is the absolute function. I'm going to put parentheses around it. There's your parent function. And in front of the parent function, what you see is the number 2. When you do this, putting a number in front of a parent function, this is as vertical stretch. For each of the points, what you're going to see is that the y-coordinate, which is 1 in this case and 2 in this case, are going to be multiplied by that leading coefficient times 2. And so you end up with a new coordinate 1, 2, and the other coordinate is now going to be 4, 4. If we plot those points, you'll see that the function is stretched upward such that it looks like that. So when you have a leading coefficient in front of a parent function, that gives a function a vertical stretch, and you are affecting not the x coordinate, but the y coordinate. You're multiplying the y coordinate by some quantity. So here we are with another example where we're going to transform the parent function, which is the square root function. So here we see the square root of x. So I'm going to put in blue here in parentheses the parent function, which is the square root function. And this time we're taking the entire function and we're multiplying that by 2. We refer to that as the a that precedes the function. So if you look back at our transformation function, we said that we could have some value a times a function f of x. So our parent function is the square root function, and our a value in this case is 2. What this means is that you're going to be getting a vertical stretch. So we're going to demonstrate vertical stretch here. When you do a vertical stretch, you are going to be changing not the x variable, but vertically you're changing the y variable. So the red dots are going to move up in the y direction, and it's a multiplication of by 2, so times 2. So for each of our ordered pairs here, 1, 1, 1 is going to be transformed to 1, 2. We have multiplied the y variable here by 2 times 2 to get 2 over here. So that point now gets stretched up vertically, and that point moves up. The point 4, 2 is going to be transformed such that we multiply the y variable by 2. And so you end up with 4, 4. So I'm going to plot 4, 4 here. What you see is that we're stretching that square root function upward. You see the new transformed function in blue. In this example, h, we again have the parent function, which is the square root function. So we have the parent function square root of x. Think to yourself, what are we doing to the square root of x function? What is happening here? What are we doing to the value of x? Well, the answer to that is what? Well, the answer to that is we're taking the x value, and instead of multiplying the whole function outside by a value, we're multiplying the function by the x value by a value b. So when we multiplied the whole function by a value, we called that a, and when we multiplied just the x variable by something, we call that b. When we multiply just the x variable by a value, that is known as horizontal compression. Horizontal compression. So what we're going to see in this example is an example of either horizontal stretch or horizontal compression. So in our example though, when you multiply, you don't multiply by 2. So our value of b in this example is 2. We don't actually multiply the x variable is the horizontal direction, by 2, but rather 1 over the b value. And so our v value is 2, so we're actually going to be multiplying the x variable by a half. Multiplying the x variable by a half. So if you identify your x variables, I'm going to underline them. These are the variables that work in the horizontal direction. You're going to multiply each of those by half. And so when you do that, this point here, 1, 1, gets transformed to, remember you're multiplying the x variable by a half. 1 times a half is a half. Anything times 1 is itself. And this variable here, when you multiply the 4 by a half, you get half of 4 is 2. So you get 2 comma 2. So what you're going to see is that this absolute value function is going to be pushed or compressed this way in the x direction. So 1, 1, let's plot that point first, is going to become 1/2 1. And so I'll change colors. I'll do the new graph in, let's say, blue. 1/2 1. So it moves over here. And this point here, 4 comma 2, becomes 2, 2. And so it's almost like if you can imagine this, we took this end of this arrow and we pushed it that way, kind of compressed. So we get the blue curve.